One way to identify some cations is to use flame tests. At its simplest, this just involves putting some of a compound into a flame and seeing what colour it goes. The reason for the colours is that when heat is applied to the atoms, some energy is absorbed by electrons, causing some of them to jump from the ground state into a higher energy level. This is not a stable state, so they then jump down, following a clearly defined path according to quantum probabilities. In the process, they emit photons of a very specific energy, and this specific energy corresponds to particular wavelengths of light. There are a few different ways to do this which we'll look at the end, but today we're just going to use a simple method, which is to soak a wooden splint in a solution of your salt and then put it into the flame. Soaking it for an hour or so means that the wood will absorb the water and not catch fire easily. It should be said that some colours are easier to distinguish than others, and also that it can be difficult to represent them easily on video. Anyway, disclaimer out of the way, let's make a start. The first of the colours we'll look at is sodium. This is an easy and pretty foolproof one. As you can see, you get a brilliant orange flame, characteristic of sodium. The problem with sodium being so bright is that it also contaminates other samples and can make some harder to see. The next one is calcium. This is often described as being brick red. It's more a reddish orange in my view. You can see a few yellowish flashes of sodium as well. Sticking with the red ones, we come to lithium. This is a lovely deep red colour described as carmine red. I'd call it crimson personally. It is quite similar to strontium, which is described as crimson. If you look at the two side by side, strontium is slightly more red, but they can be difficult to separate. Potassium though is quite different. If you can manage to get it free from sodium, you get a lovely pale lilac colour. Copper, in this case copper sulfate, is usually bright green, although in some circumstances it can give a blue colour instead. And now barium. This is described as apple green. They look like very strange apples, it's just a very pale green in my view. And finally boron. Here we're just using a metal spatula to hold a small amount of the solid in the flame instead. Traditionally you would use a small loop of nichrome or even potassium wire, but this works well enough. And as you can see, this too, like the copper, is a bright green flame. If you have a solid instead of the nichrome or potassium wire, you can just dip a splint soaked in water into your solid to pick up a small amount and then hold that into the flame, just as we did for the solutions. You can also use an atomizer bottle to spray a fine mist of the solution into the flame. Here we have potassium being sprayed. And now copper. If you want to set up an exciting demonstration, you can set them all off at once by burning a few cubic centimetres of methanol with a spatula of the solid in each one, or even soak the salt into a sugar lump and set light to that.